Hello everyone, welcome to episode 2 of How It's Made. In this episode, we go through Cave Climb. So this is the second game I created in my 1-week game series. So let's get into it and kind of see how I created this whole thing. Let's first go off and just hit play to kind of show you what the game is all about again. I'm just going to turn the volume down for myself. I'm going to increase the brightness, so hopefully you can kind of see it a little bit better. So again, this game is just all about clicking on the blocks and then climbing your way up to victory. I believe there was 5 or so biomes, each one with different monsters, and they had their own checkpoints along the way. There's of course enemies that you're able to defeat with the boomerang here, options, and all that kind of stuff. So much like the other episode, I'm going to really just go through some of the key scripts you need to make this kind of game on your own. And I'll try and show a little bit more on the engine side and how you build these characters, as well as the scripts. So let's first jump into the script. The first one we're going to kind of show you is the player script. So you can see it's quite a big script here. So let's go ahead and click on it and see what it's all about. So our player script here, we're going to need access to our sprite renderer, our animation, a transforms for where we want our hook shot to kind of start, a line renderer to draw that line, a distance joint 2D, so we know exactly where that line is ending up on. We also need our mouse position, and then I have a bunch of different bools here, so stuff like walking, grappling, being grounded, resting. Those are all of our different bools to help with our animations. Then we also have a move speed, which is pretty common. And then I actually use the universal render pipeline. 2D lights in this Unity version are experimental still, so that's why it has the experimental keyword in here. But we need it for our light source. So our light source kind of keeps the game kind of lit up around our character. And then we need some stuff for our stats. So we need to know our health bar. I also have access to the fill image of that health bar, so I can change its color. We need to know, of course, our health. We need to know about our rope's duration or its strength. So we also have a slider for that and a float for that thing too. The last part in our whole setup of variables is the gadgets. So we need some sort of prefab for our bomb. So I believe it's every time we hit space, we drop the bomb. We need to know how many bombs we have. And then we also have kind of a interface for that to display how many bombs you have and how much health you have. I think that's all part of one interface. And then we have icons for it too, so that you can see when bombs are available or aren't available. Then we also have our boomerang, and we have an integer for that as well, and then an offset that I believe is also for the boomerang. Anyways, now into our start for it, we want to just make sure those certain components that we can assign from the beginning are already assigned. So stuff like our sprite and animator, let's go ahead and assign those. And then we're going to make sure that our joint is not enabled because we don't want to see the line renderer. We're also going to make sure that our health is all kind of set up as well. And then we hide it. And then same with our rope. We also want to make sure that's the right number, and then we hide it as well. Into our update here, it's kind of short because everything is in its own function for this one. So of course we just want to keep updating our health value as it changes. And then we have our animation handling done over here as well. So whenever we move, it's going to trigger this set bool for our animator. And whenever we grapple, it's also going to set that bool too. And if we're not resting, So resting is when we're at a bonfire and we hit W, then we're allowed to move. And any other time as well, we're also allowed to do our hook shot, our rope, drop bomb, and fire boomerang. So let's go and see what each of these are. So you can kind of see fire boomerang is our first one here. So this is whenever we hit our right click and we have a boomerang available, then we're going to subtract that. So the boomerang or boomers here, it's just a value 0 or 1. It could have been a bool as well, but we minus that, so it's going to be 0. And then depending on which side we're facing is where we're going to have that offset be. And then we will create the new boomerang at whatever offset it is. And then we get our camera's mouse position, and then that's where we're just going to set its move to. So the boomerang literally just moves towards that camera spot and then comes back. So once its position hits that spot, then it comes back to the player. So a pretty simple thing here. Next we have our rope. So this is really just seeing if we are grappling, then we want to start showing our rope bar. We're then also going to be subtracting our rope strength, because you can't be holding on forever. We also update that value so it plays out for the player as well. And then if the rope strength goes to 0, then you're no longer able to grapple, and we turn that to false. If, however, you're not grappling and your rope bar still needs to regenerate, then that's where we start increasing it by time.delta time. Very handy if you're trying to just increment something in real time. Of course, updating its value, and then making sure it's still active. And then only when our value is greater than the max value does it hide. So it's kind of the same with the health, is that it hides after a certain amount of time. Next is our movement. So this is pretty easy. We really just get our horizontal movement, that's our left and right. And if we are greater than 0, that means we're facing to the right. Then we don't need to flip our character, so just make that false. If we're facing the left, we're moving to the left, and then we flip our character that way as well. And then we pretty much just have, if we are moving in any direction, then we're going to turn walking to be true. And if we aren't moving in any direction, then we're going to make it false. And then we have here when we are grounded. So when we're grounded, we want to make sure that our character can actually move. So that input that we've been getting up above will actually be useful. And if we are grounded and we don't have any input, we're also going to reset from our caked bool. So that's the one where you kind of fall flat on your face. If our grounded is equal to false, then we also allow you to kind of swing around. So that's going to be where this Y input comes for the vertical axis. So I pretty much just let you also do that. So whatever your X input is, that's going to affect your X position, and whatever your Y input is, we're also affecting your Y position. And then I just used a random value. I used 3 because I found 3 was just enough force to get you above the tiles. So that's kind of the whole purpose for that. Next is our hook shot. So that's where the rope actually tethers to the thing. So we are getting our left click, and if the mouse is not equal to 0 and we are grounded, then we're going to make sure that we aren't flat on our face anymore if that is happening. We're then also going to make our grappling equal true, so that's going to help with changing the animation. We're then going to set one position of our line to be at our mouse position and one position to be at our player's position. We're then also going to be setting our joint's connected anchor to be the mouse position. And then we're going to show both of the line and the joint so that they're both enabled. Finally, I don't want my character to continuously be falling, so I make sure that its gravity scale is 0. And then we just play a little tether sound as well. Otherwise, if we are releasing our left click, then we hide both the joint and the line, and we reset our gravity scale back to 1. We aren't grappling anymore, so that's turned to false. And our mouse position, we just reset it to a vector 0. And then we have if our line is kind of on the screen, so our joint is enabled and we're grappling and all that kind of good stuff, then we're always going to be kind of constantly updating where this position is for the part of the line for our player. Otherwise, if you don't do this, you might have the line going from where your player originally was to the thing you're trying to tether to. So make sure you're always kind of setting this position as well. Very important. And then lastly, we kind of just lerp the player to that position. So that's why when you click on something, your character moves very slowly towards it, or maybe a little bit faster than slowly, but they move towards whatever you're tethered to. This is also why you have kind of pushback when you're trying to go around the block as well. The next part here is when we drop our bombs. So if we have more than 0 bombs and we hit the spacebar, then we're going to first subtract bombs from our inventory. And then depending on what way we are facing, again, we just add like a little offset so that we can place the bomb in front of the player, which that's what we do here. We instantiate the bomb, and then we start a little coroutine. So we're going to then set active that bomb interface so it shows how many bombs we have left. And then I just do a very inefficient if loops here to just see if we have 3 bombs, if we have 2 bombs, if we have 1, and if we have 0. And then that just waits for about a second, so it only plays on the screen for a second, and then it goes back to being false. This last part, I think there might be one more part, is when we take damage. So we can take damage from pretty much anything in the game, which we then will subtract that damage from our health. If that damage is greater than 0, because I think there's some times where we do take damage and it doesn't do damage. But when we do take any kind of damage that's more than 0, then we make our character go into the hurt animation, we play the hurt sound effect, and then we also display the health. So when we display the health, we're just going to be setting that health bar to be active. If the health bar is less than 3, I believe we kind of start with 5 health or 10 health, something like that. So if our health gets low, then the color turns to red, which is why we had that fill. And if our health is greater than 3, that means we're kind of healthy still, so that will be green. If our health is less than 0, then we go into that faceplant animation. We also set resting to be true, that way it doesn't play any of the other things. And then we also transition to our lose scene. And then we wait a second for that to all happen, and then we hide the other 2 things as well. Yeah. And now we want to also rest at the fire, so when you approach a bonfire and you press W, then it will do the full heal thing here, which sets our resting to be true, sets that animation to also be that, resets our health to 10, resets our number of bombs to 3, and we then go ahead and display the bombs again, just so you can see that your inventory refilled. And then we just wait a second to then turn your resting off. So it's pretty much the whole player. I'm going to just quickly go into Unity to kind of show you all of its little pieces. So over here, let's maybe just go into the player here. So you can see this is the player here. We have our hookshot start, which is just an empty game object with the line renderer. Also has a rigid body 2D. And then it also holds our distance joint 2D, which I believe that this is all just default values. The only thing I changed here on the width was I made the width a little bit smaller on the line renderer. And then I also have this touching ground part. This kind of just helps with knowing when the player is fully on the ground or not. And then this is the point light 2D. This also increases in size every time you touch a bonfire. This is really just how we see everything in our game. Then I have a very small canvas in our world space that holds our stat bars, which is our HP, the green one, and our rope power, the brown one. And then lastly, I have the bomb image here. I call it equipment. It's again another canvas that is world space, and it just has 3 images on it, one for each bomb. I think the next thing I was going to talk about is this touching ground part, since it is still kind of part of the player. So pretty much what this does is it's going to have access to our player and an amount of fall time. So what we can kind of see is when the player is not on the ground and they are not grappling, that means they are free falling. So then we're going to start increasing that fall time. When they land on the ground, and if their fall time is greater than 1 second, then that's when we play the face plant animation. And we also make sure that the player is now grounded, so that we don't count up anymore. And then we also can reset our fall time. We also have when the player stays on ground, we want to make sure the player is then going to stay grounded. And lastly, when the player leaves the ground, then we make sure the grounded is false. So pretty simple, just a bunch of collision stuff, but it really helps with knowing how long your player's been in the air and stuff like that. Next, let's get into the block spawner. So it's going to be every section of this game's biome pretty much. So we need a couple of things. We need to know, of course, how tall we want it and how wide we want it. We also then need object to a prefab reference of our block that we're going to be spawning. We need to also know our block spawn chance. So every part in this, it's going to be a double for loop, as you can see here. To build it all, we need to know if we're going to be spawning a block on that spot or not. We then also have a sprite for the block. So most of the blocks are more or less the same, but we do want to change what the sprite looks like just so that that biome all looks the same. We also have a level, so this will just tell the block what level it is. So the first biome I think is like level 0 or level 1, and then it goes up to level 1, 2, 3, 4. And then we also have an array of what enemies we are going to be spawning here. So in the start, very much like our last How It's Made video, we do a double for loop to create the entire kind of area for that part. The only thing is here I am checking to see if I is that first row, then we are not going to build on that row. And that's mostly just to make sure that our player can get through every section and just so that they don't run into any blocks when they're coming out of the ground. So our chance is based on our number here, which is assigned based on what part of the map it is. So if our chance is 0, then we can start spawning that block. So we make a new block from the block prefab. We set its position to kind of be wherever it should be. All these blocks are one solid unit away from each other, so it makes it nice to just use ones here. If your blocks are different sizes, you may need to play around with these numbers, but you know, if they're the right size, the 1 by 1 pixel, then you should be good. Next, we make sure that the sprite on our block is going to be the one that we want it to look like. And then we also assign the level to that block too, because blocks can do certain things from that as well. And then we set its parent to the block spawner. So every biome is, all the blocks are parented to the spawner. And then we have, if our chance here is 1 less then our block to spawn. Then we're going to start spawning enemies. So pretty much just doing if, you know, we pick a number that is not 0, so not our spawning a block, but it's not one of the other random numbers that we can choose from, it is like the last number, then we're able to spawn a enemy. And in that, we then also give another random chance. So are we actually going to be spawning an enemy in here? If our spawn is 0, so you have like a 1 in 10 chance that an enemy spawns. Then if that's the case, then we just look at the level and we instantiate the appropriate enemy. So you can kind of see level 1 only has the 1, level 2 will have 2 different enemies, level 3 has 3, 4 and 5 also have 3. And that's pretty much it for the block spawner. So I'll go ahead and show you that, how it looks in here. So if we double click, this is it right here. So it's this little circle here. It has the block spawner here. I have my different types of enemies in here. Now it can't go into the bat or the cactus, but that's okay. And then this is the block spawn chance. So it's got a 1 in 5 chance to spawn a block. So maybe I'll go ahead and just hit play so you can see that. Then I'll hit pause. So now you can kind of see, and hopefully it's bright enough, but you can kind of see that the height is also 32, so it goes up 32 blocks. And then here, this next red dot is now going to be our grass spawner. So then we spawn all of the grass, and it goes up and up and up like that. And then right here, this is our sand. And then ice, and then the darkness up here. So they all work pretty much the same way. And again, all you need is the block and knowing your dimensions, and then that's about it. And what kind of enemies you want to spawn. Maybe we'll actually go into the block to kind of show you what can happen there. So there's a few different block types. Again, this is totally up to you if you want to do this for yours. So I have the normal blocks, those don't do anything. I have invisible blocks, they blink on and off. I have physics blocks, they are when you touch them, they get gravity and then they fall down. I have sliding blocks, they really just increase your movement speed. And then I have bouncy blocks, they bounce you away. So each block will have a level, a sprite renderer for changing what the sprite looks like on it, what block type it is, and just a color to kind of identify what block you're on. And then also a timer. This one is more or less just for the invisible one, I think. I used to also spawn the enemies here, but that didn't work very well. So in our start, we do want to make sure that because we are spawning these, we want to make sure they're getting their own sprite renderer. And then we have some things like if it's level 2, then we have different chances for it to just be normal or if it's going to be invisible. And then we also set a color if it's invisible. So you can see you have like a 70% chance or so that it's going to be normal, and then like a 30 or 20% chance that it's going to be invisible. And level 3, more of the same. The only difference here is the if it's physics, then we change the color to another different color. We add the component of a rigid body to it, since these blocks don't have rigid bodies, they are just box colliders. And then we make sure its gravity scale is 0 to start, so we can increase it later. Level 4, we use the physics as well, and then the sliding. Level 5 is when we add the bouncy and the sliding as well. And then just a little bit in the update here, if it's invisible, that's where we make it blink. So we have a nice little timer here. If the timer is greater than 2, so it's been about 2 seconds. If the sprite is showing, then we're going to just disable it and its box collider so that you can go right through it. Else if it isn't enabled, then we do show it again and you can land on it. And then here on the collision, this is where some other magic happens. So if it's physics, then we just set its gravity scale to 1. If it's sliding, we just increase the player's movement speed. If it's bouncy, then we kind of see which side the player is on and then just add some force to that side. And then only when we jump off the sliding block is when we really care about doing something, and that's where we make our move speed back to equal 3. Since this video is getting kind of long, I'll kind of just move along to the enemies here. So the bat is one of the enemies that actually can like move around randomly and then seek you when you get close enough. So it's one that I kind of wanted to touch on. So we have a radius here to kind of know how far it can travel. It wants to know about the player as well. It needs a timer to know about when it needs to make that decision. A bool when it knows when it's chasing and when it's not. A destination for it to go to, and then a particle effect for when it dies. So when we start, every bat will find the player and assign player to the player. And then it's also going to set its destination to just be itself for now. It will pick a new destination every few seconds, I think, where if it is not chasing, then it just kind of finds a random thing within its radius and then just sets that to be the new destination. And then if it's going one direction or the other, then we just flip it as well so it looks like it's going in the right direction. Here in our update, we calculate a distance every frame to know how far the bat is from the player. Once the player is within 5 units or pretty close, then the bat will start chasing. This is pretty much like a screen width away. It will start changing its position to be a move towards. So it's going to move towards its position to the player position. And then again, just flipping it in case, it's on the left or right side of the player. If the distance is greater than 5, then we make it not chase anymore, and we start increasing the timer. And then that's when we have if the timer is every 2 seconds, pick a new destination. And then we're moving it to that destination. Just when we kill the bat, this will be the same as our beetle. We hide the sprite renderer and the box collider, and we make sure it doesn't go anywhere either. We play our little effect, and then after a second we just destroy it. And then it just does damage to the player. So that's really the bat. I will show you the prefab of that. That's the guy. And that's about it. So it's really just a sprite with that. Same with our beetle, pretty much more or less the same thing. But he has a front sensor, which is going to be kind of just a little dot right in front of his hitbox. And you'll see why we're doing this. So we go into the beetle script here. They have a front sensor, a direction, a layer, and a particle system effect. Pretty much what it does in our update here is we have a hit down. So we want to know that we're shooting a raycast from our front sensor, and we're shooting it down. And we're shooting it down just 1 unit. That's all it really needs to be. And then we're also shooting a raycast forward from our front sensor, and we're shooting that to the left of it, since it's facing left. And that's just a smaller one, mainly because I don't want it to see a wall and then not go that way. So far, collider is equal to null. So both of the colliders, or if the hit down collider is nothing, or we are hitting something with our front collider, and then that's when we just kind of flip the character. So we just multiply its local scale on the X by -1. So every time it hits a wall or hits the end of its platform, it'll just reverse position. And then of course we just add that to its X position here in the form of direction. And then again, it does the same thing as our bat, where it dies, we hide some certain things and play its effect. It does add some force when you touch it as the player, so depending on whether you're on the right or left side, it'll give you some force in that direction, then also just deals some damage. If it collides with another beetle, then it's going to just reverse its direction as well. And then the very last thing I wanted to show is the bonfire, mainly because this is something that was cool that I found out. So of course there's a particle system on the fire. Can't have fire without particles. We have a bool for being inside the fire. And then we just have a light source as well. So we have a minimum intensity and a maximum intensity. And then we also have a flow. So of course we want to make sure the light source is going to be the bonfire's light source. And when we are in the fire and we hit W, then we're going to play the particle system. We are going to play the rest at fire from our player. We're going to take no damage just so we can show the bombs. We're then going to also increase the outer radius of our character's light. We are then going to disable the collider for the bonfire. We're going to increase how many bonfires we found, so increase that little score. And then we also play a sound effect for it. And then this is where it is. So the flow, it kind of makes it go from like dim to bright to dim to bright. So that's pretty much what this is doing. So while its intensity is at the min, then it flows back up. And while its intensity is at the max, then it flows back down. That gives you kind of a nice effect that the light's a little bit more dynamic than just a solid light. And then the last part here is just whenever we enter it as the player, we just set this bool to be true. So to kind of show you that again, maybe we'll just hit play so you can see it live play actually working. So as you can see, its light was going up and down, so it's being somewhat dynamic. And yeah, that's pretty much about it. If there's any other things that you want me to discuss about this game, or anything else in that nature, then let me know in the comments section below. Otherwise, you know, go back into the code, into the different parts, and you can definitely use all of this code in your own projects. And I hope you enjoy the rest of your day, and I'll see you on Monday for a new 1 week game.